So on the second day of this course, we are here to talk about a very relevant topic, that is understanding disease data variables, the way medical parameters are selected, labeled, and recorded. We have a diverse audience connected in this course, and we have many experienced doctors with us, but at the same time, we have several researchers, beginner students, and few people from the industry background as well. So this session is essentially added here just to ensure that we can bridge the gap between diverse range of audience that we have. I suppose the doctors who are already having vast experience in this domain, they know how disease variables work, how medical parameters are handled, because they are well expert in that case. But yes, to just bridge the gap for the remaining sessions further in this course, we are essentially talking about this topic here. So that those who are beginners, who are students yet, need to learn about how we can process medical data for leading any application in Python programming or maybe in data science, AI, etc. They can understand at least the basic factors behind, and then further, definitely they can develop a better understanding as we proceed with the remaining sessions of this particular course. So the outline for today's session we'll have here is, we'll first try to understand what type of disease data we generally have and how they originate from real world. That kind of discussion we'll have here. Then we'll identify some relevant variables with reference to disease problems. And we will see how those variables are organized together to make predictions or to gather them as some input variables or output variables together. So with this raw data that we get from doctors, from patients, from the reports that we have in the hospital environment, how we move forward to create some structured or unstructured information that can be utilized for decision making further. And the best part, with all that information from the medical domain, how we connect it with the AI and data science, the emerging technologies, that overview we'll try to get in this particular session. Before I proceed ahead, I would add a disclaimer over here that this presentation does not use and or display any real patient data. All examples, datasets, case scenarios, and screenshots shown during this session are synthetic, anonymized, or publicly available sample datasets created for educational and research purpose only. We don't have any identifiable patient information from any hospital, clinic, or healthcare institutions used for this session. And we have accessed all the material that is exclusively available online at different publicly available sources for the learning as well as for academic discussions only. So while be showing different patient records further, so all of them are just some synthetic data sets, so that we do not hamper any patient privacies while discussing these concepts. But as we know that these are some important factors to be discussed to merge these two domains together, like healthcare and data science, we are trying to merge together. So definitely we first need to understand how data originate in the hospital environment, and for that a study over patient reports, patient vitals is essential for us. And with that perspective only, some anonymized or synthetic data set only I'm using throughout this discussion further. So moving ahead with the very essential details, understanding what are disease data variables for the students and for researchers, how you start with a collection of your data. Because it is important to mention here, while I was preparing for this session, when I was gathering relevant information, it amazed me that how at every onset in a hospital environment, in a clinical scenario, or anywhere wherever a discussion between patients and doctors is involved, at all those places we generate massive amount of data. And being a data scientist, being a AI engineer, I would always admire the bulk of information that we are able to gather from every scenario around. And this possibility, this huge or massive availability of data set in almost every scenario in the healthcare domain make it most suitable domain to integrate with the AI domain. And that personal observation I have made while working over several healthcare studies within past several years, while collaborating with several researchers who have relevant patient informations to do some research analytics. Every time I have observed this, that there is a huge set of information that can be utilized to integrate into the AI domain applications, and we can definitely set new markers in the domain. With that idea only, we are going to discuss variety of things here, and whatever ideas we are gathering from this today's discussion, that will be utilized further in the upcoming sessions when we will be doing hands-on practice for data analysis, for handling patient disease variables, etc. So this will set up a foundation for all of the beginners over here. So moving ahead with the concept, the core idea here is when we talk about disease data variables, they are basically some measurable clinical attributes that help us to define patient health status and condition at a given point of time. And there may be a very large range of variables that help us to get relevant information about patient health issues, and they get originated at different levels in healthcare system. It helps us to understand, classify, monitor, or predict disease conditions for the patients. So, when as a doctor you might be evaluating your patients, there are in your regular practice, you keep on writing several summaries, you keep on writing several patient vitals every day. And when we organize that data into a adequate format, that data can be further utilized for training various AI or machine learning models and to make direct predictions out of that. And of course, the main idea here is to somehow integrate technology into the system so that we can ease the diagnosis process. We can fasten up the diagnosis so that patients who need immediate treatment, they can be saved on time before it takes time to diagnose things, or if it gets delayed by certain chances. So if technology can assist us in this entire progression, maybe we can treat some critical patients ahead of time, because as we consider the population burden over the years, and the burden on the doctors also with time, because the patient count in the hospitals is increasing with every passing day. So in that scenario, if technology could assist doctors also somewhere, and caretakers or nurses, etc., if technology could assist them at certain level, that could be a huge burden share from the both sides, including the patient side, including the care providers or the doctor side as well. So while working on these different stages of patient interactions with the doctors, with the nurses, with the caregivers, we get variety of variables in hand. That could be variables about presence of certain disease or absence of certain disease. It could discuss the severity of certain illness. Progression of symptoms also are reported with time to time as patients come for a visit into the OPD, or they discuss maybe every month or every week as they discuss their symptoms with the doctor. So that progression also gets into the records, and various type of changes that they are feeling in their body, in their regular day-to-day activities. Everything can be recorded easily with that regular measurement over clinical variables. And of course, the response to treatment with reference to the medication that is given to that particular patient. So we are just getting an overview of all these clinical or healthcare variables basically, and we need to observe them in a specific pattern that can be utilized in a tech-savvy environment. So for the researchers, it is important to understand here that why you need disease data variables basically. Because healthcare analytics completely depends on the structured information. And disease variables at initial level, on the medical point of view, we can say that it helps doctors to make decision about the disease, make decision about what kind of treatment is suitable for the patient and what are the progression with time. But as a researcher, this is going to bring you variety of details further. Or as a multidisciplinary researcher, if I talk about, like if you are a medical professional or a medical researcher who is gathering patient information or some researchable information from different health conditions, and then are willing to use some data science, AI, or machine learning or deep learning based modeling to make some predictions further to ease the diagnosis process, then also it is useful. And in the similar manner, if you are engineering background student who are interested to enter into the healthcare domain for designing some new technology to assist patients or doctors, for you also this structure of data variables is going to be very much essential. So in this process, we need to understand that the human health conditions are required to be converted into some quantifiable information, because in hospitals or clinics you will find information in variety of forms. You have patient summaries, you have nursing notes, you have some medication histories, you have some disease progression histories. So those are generally some textual informations. And in some formats, you will also find details in the form of yes, no, or maybe certain values reported during the medical histories or maybe reports of the patients. So the main idea here, while we have to develop some data science based project or maybe some data analysis we have to do, we need some quantifiable information. At the same time, we need some information that can help us to compare patient records or patient disease progression with various medical descriptors. And we need to build data set in such a pattern that it is suitable for statistical analysis and machine learning, because there are some set patterns of data that are utilized while building these kind of modelings further. So we will discuss that part also in coming days of the course, that what are the standard versions of the data that are generally preferred while building some machine learning models or data science based analytics. So those will also come into the role play in the coming sessions of this course. So it will also assist further to track disease patterns and treatment outcomes, which is very essential to understand how well a patient is able to recover after a treatment, or maybe if certain treatment is not suitable to certain kind of patients. So that kind of analysis also we are able to get from the daily healthcare records or reports that we are getting from the hospital environments. And similarly, the support evidence based decision making we are getting with this structured information only. So without these variables, the patient data stays unstructured, because generally, as I told you, those are some subjective summaries you get. So until and unless we structure them into a relevant format, they cannot be used directly in AI and ML. And with time, like if we see over the years how things have changed in the medical health industry also, many of you might have experienced that at present, many hospitals have started recording patient information in the digital versions of the copy also. Few years back, everything was on the pen and paper, and only the physical files used to exist for patient histories. But now, with time, the digitalization of information is happening everywhere, and that digital version of information can be precisely used for various types of decision making easily, because that is easier to access for research. But at the same time, While talking about medical histories or medical records, etc., I should mention right in the beginning that privacy is always a major concern. We cannot disclose patient informations without consent. So, as a researcher, you also need to keep that in mind, that whenever you are working on any medical data set, always be careful about GDPR rules, the law that protects patient rights. And definitely, we cannot share any of the patient personal informations publicly. So you need to adhere to the rules for that. There are some particular legal restrictions, and based on that only you can access patient information by removing all the personal details of the patients in that case. So for that, definitely there are some procedures that researchers need to follow, and after that definitely it is possible to set up your data variables into AI models directly. So moving further, if we just get an highlight of some major categories of disease data variables that you will generally find from different types of hospital records or histories, etc. So you can observe from this table that almost at every stage of patient doctor interaction or a patient movement in the hospital wards or maybe laboratories, etc., at every step different types of variables are gathered. We will also discuss this thing in very detail in this session further, but just some key insights I'm giving here, like some demographic information we collect when patient enter their initial records, maybe at the time of patient registration itself. We come to know about their identities and some risk indicators, etc. That may include age, gender, BMI, etc. The initial information is directly available from the registrations. And then symptom information during patient interactions with the doctors, they will tell them about the symptoms, etc., that they are facing, depending upon what kind of disease they have. And there may be some physiological measurements also that may be followed by the doctors in the OPDs or during clinical appointments. So there may be several vital signs that will be reported depending upon patient conditions. And further, if some laboratory tests are suggested, so based on that, there may be several biochemical markers that are reported with some quantifiable values indeed from these laboratory tests that could be really useful for predicting disease conditions present in the patient. And in some disease cases, there may be image or video based findings also, including X-rays or ECG patterns, etc. So in some cases, that kind of information may be available. And with the progression of certain treatment, then the information about medication doses, oxygen therapies, and procedures, etc., may be also available, and along with the outcome variables at ultimate stage, whether a patient gets recovered or they are shifted to some critical care units, or maybe the different scenarios that we can have during medical histories of a patient. So this is just a quick overview of different variables. Further, I'll be discussing these things in detail also with different types of forms that you may have generally in the hospitals, and what are the key indicators over there that you may need to keep in mind as a researcher to gather your quantifiable variables, that we will be discussing further as well. So moving to the essential details further, for instance, how certain disease data variables are going to represent certain health conditions. So for the experienced doctors who are already practitioners in the medical community, they might be already aware about these. But some beginner researchers or participants from engineering background, there will always be some connections between different variables that we record from the patient histories, and they are indicating to certain kind of disease, whether it is present in that person or not. Like for instance, if a certain person is reporting some symptoms of like fever, cold, cough, etc., so that will be linking somewhere to underlying infection or inflammation, etc. So doctors could recommend things according to that. Similarly, if based on some test results or reports, if certain variation over blood glucose level or maybe oxygen saturation or maybe ECG ST evaluation are done, so that may be indicating further to certain kind of disease that could be related to maybe diabetes, maybe heart disease, or maybe some other inflammatory responses. So that history you will get from the patient records always, and depending upon what kind of symptoms a person is facing, always a certain set of records you will find from their medical stories. And as a researcher, you need to focus on the essential factors that can contribute further in your machine learning model building or in your data analytics. So I'll tell you further that how those relevant variables you will be able to identify, and then you will be able to set up your data set for this purpose. Let us talk about how medical parameters can be selected for leading your data analysis or maybe machine learning or AI based modeling further if you have to set up. Definitely in tomorrow's session, I'll give you more insights about the core of data science and machine learning. So whatever we are discussing here today, that will be able to connect into this other domain. Like, because we are combining here two domains together, medical domain and data science AI domain together. So today's observations we are making on the healthcare, that what are the focus points in that area to merge with the things that we'll be discussing tomorrow, so that we can take both these things together to implement things in practical scenarios in the coming sessions further, and then it becomes a deployable solution for the real-time scenarios, and we can set up certain real-time applications to assist patients, doctors, etc. by using that information. So moving forward with this idea, why parameter selection matters, that is the first important thing as a researcher you need to know. It is important to mention here that every time a patient visits a hospital, there are unlimited number of parameters reported. At every stage, a different set of parameters are reported. But not every recorded parameter is equally essential for your research analysis. So whenever you start working on certain project, you may have a hypothesis in your mind for leading your data analytics or maybe for building your machine learning based analysis. You may have a hypothesis in your mind. So all the variables that you will be selecting, they should be based around your hypothesis. So that is why we generally say that there may be hundreds of different parameters or vitals that you may be getting even from a single patient who is undergoing certain type of treatment. But it is your call, your clinical judgment, your specific understanding on the topic, and your ability to get medical evidence from those attributes that will help you to select most relevant variables out of the entire insight. So sometimes what happens, people even get quantifiable information into their Excel sheets or CSV files, but when ultimately you have to build some machine learning based model or you have to use AI for predicting something, many times we make a mistake of putting all those hundreds of variables into the machine learning model for making prediction. But that is not always the required case. We always have to do a careful synthesis of available variables. We need to choose the most relevant one and discard the remaining, the unwanted ones, and then only those relevant variables or most contributing features can be utilized for final decision making. Like for the medical histories, there may be a large set of variables required, but depending upon the domain expertise into the medical field and into the data science and AI field, a collaborative effort of both field experts will be able to decide what variables are most relevant among others. And there are some proven algorithms also that are already available in the research papers that you will already find from the AI community that are well tested on a selection of different set of relevant variables out of a long list of variables. So those variables, etc., how we identify them, how we select the features, that also is an essential thing to understand while we build something in the AI field. So but that kind of discussion, although is not a part of this level 1 course, because in level 1 we will be discussing very basics, so that you can just get the initial understanding about the topic and how you deal with the medical parameters. And as this is a 3 level series, in the second and third level further we'll be introducing how practically those features are selected into the machine learning models, and how those models adapt into certain decision making for patient conditions, or maybe certain kind of outcomes that we are expecting from the model itself. So while making selection of these variables, there are some uh, parameters that we have to keep in mind. For instance, your selected parameters should improve diagnostic accuracy. They should be capable enough to contribute positively in your decision making. So for that, definitely you may need assistance from experienced doctors in that field for which you are working with. Like maybe if you are from some engineering domain, not from core medical health domain, a researcher who is trying to work in on patient conditions, uh, while working on interdisciplinary research field, they may need to collaborate with some experts from the medical community, and they can help you guide on what kind of essential variables can assist you to improve diagnostic accuracy. And there should be variables that help you to identify risk, prognosis, and severity of the disease, so that AI model can understand those things pretty well for any kind of decision making. Similarly, we need to build clinically safe AI and machine learning models, because healthcare is one of the most critical domains where we may need to implement AI these days, because here we are dealing with lively patients, we are dealing with living things over here. So we cannot use a model that gives maybe 70% or 80% accuracy. That is not reliable in healthcare domain, because it deals directly with the patient outcomes. If a model is making wrong prediction, and maybe a patient who is suffering from a disease is diagnosed healthy by the AI model, and he doesn't receive treatment on time, that will be a big risk on that person. And the vice versa can also happen when a person is not affected with any disease, but still, if AI model predicts that he is suffering from certain disease, so he may receive wrong treatment in that scenario, and that is again a critical thing in the medical history of that particular person. So we need highly accurate and clinically safe AI ML models. So that this is definitely a big responsibility for those who are trying to utilize AI for this domain. But of course, if we follow educate approach, if we avoid any unnecessary noise or bias in the data set, and if we are using right set of variables, we can definitely improve insights from the data, and we can improve the prediction accuracies of the model. On the other side, selection of wrong variables can reduce clarity in model building, and definitely the outcomes will be also reduced in that case. So moving further, the foundation of parameter selection that we can keep in mind while setting up your research documents or your data set for research, there are 3 important questions that you may need to keep in mind. First thing, the attribute that you are selecting for your research study, are they influencing the disease or not, or how well they are connected with your disease progression? Because at initial set, there may be a large number of parameters that are recorded from the patient, but which ones out of them are actually contributing or influencing your disease progression, that you should be able to identify. At the same time, you need to use variables that can predict treatment response or outcome. whether the variables that you are selecting, they are directly connected to the outcome or not. That thing you have to keep in mind. So parameters are selected not because we have them, because we may have hundreds of parameters, but we need to select them because disease physiology demands them. And when we have to make a decision about existence or non-existence of certain disease in a patient, there should be relevant set of parameters available. Like we can say, in a general procedure, sometime when you have your medical histories as a doctor, maybe sometime if certain patient report or test report is not available, maybe you may not be able to give your quick decision about whether the person is suffering from certain disease or not. So you would recommend them to bring the test report, then you can analyze those variables and then you can give that decision. Same goes with the machine learning model also, that need the initial significance first. It works in the similar manner. We need to train it to understand the initial significance first. What are the current conditions of the patient, what kind of histories they are having, and based on that they will be able to, the machine learning model will be able to make predictions. So we always need to ensure the most relevant set of collections for the clinical relevance that we could teach to AI model. We need to mention that not all variables matter for all the diseases, because as I told you that there are several details of the patient. Just few quick ideas I have listed here that are generally available from patient registration forms as well as from the OPD summaries directly. These kind of things you will find, or some of these things will be available from patient test reports also. But you need to check which is your target variable for certain hypothesis. Maybe some of you might be working on maybe diabetes case, so your set of parameters may be different. The one who is working on heart disease progression, their set of parameters may be different in that case, so accordingly the selection will be done. So just for a quick highlight, we can have here, like if the disease list, we can have something like this. Maybe hypertension is your target area in which you are working, so BP may be a relevant thing in that case. But if in your patient summary, if this variable is also available, then this will be irrelevant, you may have to skip it in that case. Similarly, for a patient suffering from diabetes, maybe he has multiple types of reports due to his past multiple histories of different medical conditions. So out of that, which ones you have to select? So in that case, if you get maybe X-ray report and blood glucose together, you have to choose that blood glucose is more relevant for you to make decision about diabetes, not X-ray. And same goes with the remaining diseases also. So collecting everything does not automatically improve prediction. Rather, we need to choose variables that are related to disease mechanism. There could be several details available from every patient histories, but you have to pick the right ones so that your AI model can make adequate judgment. For instance, let us take it into the practical scenario. If we talk about practitioners or the doctors who are already expert in that particular area, if you bring to them both types of report, like you give them blood glucose level and X-ray also, both you give to them, but the diagnosis is going on for diabetes. So doctors already know that, okay, I have to focus on blood glucose. They will not take this X-ray report. They will say that we just keep it, we don't need this, and we need the blood glucose report right now. So in the similar manner, we need to teach this thing to a AI model also. It learns in the similar pattern as we human beings make decision. The same thing. AI is basically the mimicked version of human reasoning. So the way we make decisions, we reason over something, the AI models do the same. But we need to justify things in the beginning to it. So a AI model initially is not able to decide whether X-ray data is useful for its decision making or not. So if we are providing that data to an AI model, it will use this also and this also, and because it has some irrelevant variable with it along with some relevant variable, chances are that the irrelevant variable may dominate the decision making process, and the AI model will ultimately end up predicting wrong things. So we cannot say it same as medical doctors who know which report to be accessed and which to be discarded at certain disease decision making. But for the AI model, we as a model trainer or as a researcher or as an engineer initially need to decide which parameters are to be fed and which are not to be fed to lead that particular model. So this is how general training goes on, and as a researcher you need to keep that in mind, that how you have to pick up those variables. So if we design maybe some clinical support systems with AI, or maybe healthcare support systems with AI, so all of those systems may have their own significance. They may all have their different set of requirements depending upon what kind of assessments they have to do. It is not possible that a single AI model can do everything until and unless it is rigorously trained to do all those tasks. Generally, a single AI model, we train at a very initial stage, I can say, we train it to work on a specific thing, like a AI model that can predict over diabetes scenarios, or one more AI model that can predict over pneumonia scenarios. There may be different onsets because those models are trained over those set of relevant parameters. And there may be some chances when we are using multi-disease prediction models, but those models in that case are trained to understand multiple disease scenarios. It is not like a direct analysis that any random model can do. Like same goes with the doctors also. They may be expert. Some doctors have specialization maybe in maybe skin specialists they are, or some doctors are heart specialists, some doctors are brain specialists. So they all have their own area. Same goes with the AI models also. Every model may be trained on different areas, so accordingly that could be used for the prediction further. So with this, we need to understand that labeling of variables in healthcare data becomes very essential in this case, because the AI model is dumb initially. We need to teach it with the help of educate labeling over the variables. And for this, first thing we need to understand why this labeling is going to be essential for leading any of your data analytics or machine learning project. First thing, it will help you to understand what information we are using to make predictions. And at the same time, it will help you understand what final predictions you are expecting from your model. When everything is labeled well, both ways you can make decisions perfectly, like what contributing variables we have and what final outcome variable we have for based on your hypothesis, because every research start with certain hypothesis. And even if you are deploying certain automated AI based system in the hospital environment, that also will have some hypothesis behind, like based on these patient parameters it has to predict this thing. Or maybe a very general case, if even if you are not able to understand patient vitals, maybe a very general case I can consider, like based on the insurance details of a patient, we can make a decision about whether he is eligible for insurance in certain disease case or not. So that insurance information will be first fed into the model, like what kind of package subscription they have, or what kind of maybe whether it is a recent insurance plan they have taken, so whether it is activated yet for the benefits or not. There are plenty of things. So maybe those dates or maybe those package details, there may be several variables available in your insurance document. So they will be fed into a certain software that could ultimately make decision whether this person is eligible to get benefit on current date or not, or for certain disease whether that is included in the package or not. So there are plenty of things we can do in this area. Now, for the correctly labeled data set, It can bring us some meaningful clinical insights. And on the other side, the wrongly labeled dataset can lead to unsafe outcomes, which is very dangerous, especially in the medical health community, as I told you, because we are dealing with live subjects over there. So with this, there are generally two types of variables that we need to keep in mind when we are working on any AI-based modeling. We call them in two categories. The first category I'm telling you is input variables or predictor variables. Coming into little more technical terms now that are connecting both these domains together, the healthcare and AI, we are connecting together now by using name of variables. So predictor variables are basically the clinical parameters that are used to estimate, diagnose, or predict certain health outcome. So they represent the possible causes or maybe the symptoms reported by the patient or the risk factors reported or maybe the indicators that are initially associated with the disease or are reported through either patient discussions or maybe reports or OPD summaries, etc. Everything will be synthesizing for this, and the predictor variables are available from there. So some examples for this we can have is like maybe the WBC count of the patient, or maybe the fever duration, or maybe the oxygen saturation level, etc. That can help us to predict pneumonia cases. Similarly, the BMI of the patient or the blood glucose level, they can further assist in prediction of diabetes. Note that I'm just highlighting only a few variables here, just for a quick understanding. Otherwise, there are many other variables also that will be utilized. Here, I have just listed few of them. Even for a general disease prediction or diabetes control case, there may be 10, 15, or maybe 50, 60 different variables that may be utilized. So that is an extensive case when you do actual research study. Here, I have just used some highlights that can guide you for the decision making further. So these predictors are also named as independent variables. This name is pretty commonly used while anyone is working in AI domain. Independent variables are the ones that are influencing certain outcome. Like for instance, if a person is suffering from maybe cold, fever, and maybe some other relevant symptoms like maybe throat irritation, these are all independent variables, or we call them predictor. And maybe there could be a final outcome variable that could be inflammation exist or not. So based on all these symptoms reported, or based on all these independent variables reported by the patient, we can take it to the target variable further that help us to know whether the person is suffering or not from certain disease. So the second category of variable is target variable or output variable, we can call it. So target variable are the final outcome or conditions being evaluated in a certain case study. They are generally the final goal of your dataset while setting up a AI model. So when we design certain machine learning model, at an initial stage itself, we define what is our target variable and what is our input variable, or the set of independent variables. And it is important to mention here that depending upon the hypothesis or the type of study you are doing, there may be one or multiple input variables. When we have linear regression, like simple linear regression is a common terminology that many of you might have heard. Even if you have not heard, don't worry. In maybe some coming days, we can discuss that in detail. I hope that is a part of our level 2 series. There we'll be discussing different types of regression models in detail. At present, we are just getting the overview of things. So for instance, if I give you a quick overview, that a linear regression model at basic may have one independent variable and one dependent variable. Means one contributing variable and one outcome variable we are going to have. So there may be a linear relationship between both of them. So this side may be if you have outcome variable, and this time decide if you have predictor variable or maybe the input variable. So that kind of linear relationship you are going to have. But this scenario is not possible in real time. Very rarely, or I can say like this is almost impossible to have a linear relationship every time between variables that you get from some real time case studies. Majority of time, the medical health indicators or variables that we get, they have non-linear relationship with the outcome variable, and for that we need non-linear models majority of time. And there is a very long list of non-linear models also that we can deploy in certain scenarios, but currently that is not our area of focus. We are currently understanding the predictor variables only, so modeling part that will be discussed in future somewhere. So we are just understanding that there are two sections always. You start with certain hypothesis. You may have certain goal, like maybe some of you might be working on diagnosing pneumonia. And for this, the predictor variables you may have, I have just listed a few only, like maybe the fever conditions of the patient, CRP, WBC count, or maybe SpO2, X-ray score, etc. And based on this, you are able to predict whether person is suffering from pneumonia or not. So these become your input variables and this becomes your target variable. Same goes with some other areas, like maybe predict ICU shift for the people, or maybe the nursing staff, or maybe other candidates in the hospital environment. So depending upon these things, these variables available from the patient, whether he requires ICU transfers or not, accordingly we can decide that, and based on that we need to identify availability of beds in the ICU. So that could be another case study required. Furthermore, prediction of certain surgery, for that also there are a set of variables. So for that, the duration, based on all these things, we can predict in advance, and so on. There is a very long list that you may have on your count, and there are a large range of variables that may be occupied in the healthcare community, because there are unlimited types of diseases also that are progressing with time in our communities, and each one of them have a unique set of variables associated to them. So based on that, predictor variables and target variables are going to change. Now, there comes one important parameter: classification and regression labels. This I'm essentially highlighting here, although this is generally a part of when we study about machine learning basics. But here the reason to highlight this is so that the beginners can at least have an overview what are the possibilities for their research generally. In majority of cases, either you go with classification case studies or regression case studies. And how do we decide over that? For the classification case study, as the name indicates, there are some classes involved. So your target variable in this case is categorical in nature, or it contains a class label. For instance, if your target variable is presence of sepsis, so there could be two states: yes, no, or maybe 0, 1. That could be the state. So this becomes a class, two classes only. Similarly, some risk categories of certain disease you are checking if there are again two categories: low and high. So if your target variable is organized in this type of data pattern, that becomes your classification case study. This is just the technical terminology I'm introducing here. So maybe in future, if someone asks you, like when as a medical professional you are trying to collaborate with some AI engineer to lead your research study, so sometime that engineer may ask you that what kind of study you are planning to do, whether it is a classification study or regression study. So you as a medical professional even can tell them quickly by understanding this fact only, that you are doing a classification case study. Like as a researcher, if you are just trying to check like if these and these variables are present in a patient, we can decide whether he is suffering from pneumonia or not. So that becomes your classification case study. So when collaborating with an AI engineer, you can just tell them quickly that, yes, I have these kind of variables. So this is going to be a classification case study, and accordingly, we can proceed further. So this kind of information, if you have, this could lead to a healthy collaboration indeed. And then the second category we have is regression case study. So we may have numeric or continuous variables in this case, like some long range variables, continuous variables, or floating point numbers are the chances we can have in this area. So it could be like predicting blood glucose levels of a patient, maybe the length of stay in the hospital, or maybe the mortality risk score of certain patient, if you want to include, that becomes a kind of regression study. So when some numerical outcome variable is involved, not this type, this is a class variable, because two categories, 0 and 1, those two categories, we do not call it a pure numerical variable. This is a digital kind of thing. This is on off only, or true false, or yes no. This becomes a class label, although it is in the form of number. But here, in case of regression, you have pure numerical data. In future studies, when we progress with this course further, I'll be showing you practical data sets also. And from there, you will be able to identify how we choose different variables and how we deploy them into AI models practically. So moving forward, now in the classification case studies, because majority of time we have seen that people go with the classification case study. So there are further few categories also that you may need to identify. Practically, how you can identify them, there could be a binary target or a multi-class target. So as a beginner researcher, when you are identifying your target variable, you can also check how many unique classes it has. For instance, if you are just checking existence of certain disease or not, there may be only two classes. So if there are only two output categories, it becomes binary target, and we call it a binary classification problem. So these are basically subcategories of classification I'm telling you further. So first one becomes binary classification problem. Second is multi-class target. When there are three or more categories, maybe you have taken vitals of a cancer patient, and from there you need to identify on which stage his disease is right now. So there are four different possible stages maybe. So this could become a multi-class problem in that case, because we have more than two categories here. And similarly, severity level of certain disease, if you are trying to identify, so that could also have maybe mild, moderate, or severe, etc. That again becomes a multi-class problem. So number of classes in the target variable have a huge impact on architecture as well as accuracy of the model. However, both types of case studies are commonly done in healthcare domain, so you can have any of these in hand. And even in some cases, regression studies we have also seen in medical communities. So that type of data sets are also easily available on various platforms. And even if for the practice you want to see, there are many sources available. That definitely those sources, etc., I'll discuss maybe in future in some sessions. So that will give you more idea about how at least some practice data sets you may get. It is important to mention here that doing a wrong mix of input and output variable can be dangerous for setting up your machine learning models. Like when you are doing data analytics, when you are working on machine learning, if your labeling is not right, it could lead to misleading results. Sometimes people are not able to choose their target variables accurately, and then the outcome is also very bad. So it is not always about poor performance of AI model. Rather, it is about poor selection of variables at initial level. There is a very common saying in AI and data science world: garbage in, garbage out. Garbage in means if we are putting wrong set of variables, or like a very bad collection of data into a AI model, the outcome will be also disastrous. So always make sure that you are inputting good set of information into a AI model, then only it will be able to predict better. So this goes in the same pattern as we see it in day-to-day responses in the medical communities. If you present some false reports to the doctors about patient histories, the diagnosis will be bad. Same goes with the AI also. If the initial reports are not good, if they are like some fake reports, or the readings are not taken accurately, or variable labeling is not done accurately, the prediction will be also bad. So these things, as a researcher, you always need to be careful. I always suggest researchers to ensure that your variable collection stage or data preparation stage is the most critical one. Setting up AI models is easier at later stage, because if you have healthy data set, if you have good quality variable collection, definitely your AI model is going to predict well. But if initially you are doing like a very uh, improper data collection, or you are in a hurry while collecting your data, you may end up getting some wrong clinical variables, or you may do some misleading interpretations, and that could hamper your entire outcome from that research analysis. There are some best practices that you may need to follow while selecting your target variables. For instance, this should be clinically relevant and medically validated. You may always need some suggestions from the medical experts while setting up your modeling variables. So that is why we generally suggest researchers to go with multidisciplinary research. But in that case, always get some suggestions from the medical experts. We need to collaborate together, then only we can come up with some good outcomes. It is not like any individual person while sitting in a room can do all the good predictions. That is not possible. You need contributions from the domain experts, or maybe you need to learn the extensive literature. That is another possibility. If domain experts are not available in association, maybe you can go with in-depth literature that can guide you better on how a clinically relevant variable can be selected. Similarly, you need to ensure that the variables that you are selecting, they are available for every patient, because when you are training a machine learning model, you will be inputting data from multiple patients in that. And if there are some variables that are available from certain patients and not from others, you will have a lot of missing information in your data, and that leads to improper model training and a bad prediction as well. So always make sure that as a researcher, when you are collecting data, the same set of variables are available from all the patients that you are considering for your record keeping. So those maybe the patient vital sheets, or maybe the report summaries, etc., should be adequately maintained by you as a researcher. Or maybe if you are collecting it from certain hospitals with certain guidelines, you need to assure that whatever data you are collecting, that is containing all the relevant set of variables from all set of observations that you are collecting from different patients. And there is one more important thing. You need to ensure that all the variable collections, especially the target variable, is consistent in terms of unit, scale, and classification boundaries. Because sometimes what happens in the practical scenarios, like if 5 different researchers are collecting data for same project, maybe they are visiting different hospitals and they are collecting their variables, so chances are that each one of them is using different scale or different unit of measurement for filling in patient summaries or patient reports. So in that case, you may have ambiguous data, and that could lead to misleading interpretations at the later stage. Similarly, in the hospitals also, they follow very practical standards that are equally followed in every case. If you can say, like, if every doctor start measuring it in a very different unit, and then when they have to transfer one patient to other doctor due to some reasons, then there will be a very huge discrepancy between patient variables in that case. So there is a common tactic that is followed by everyone in that case, and the same goes with your AI model training also. There should be a consistent scale, unit, and classification boundary associated to your target variables. Now, moving further, let us discuss how variables are recorded in the clinical systems, how these things happen at different levels. So very first thing we have to keep in mind, The format of your variables should be very concise. It should be consistent during all the recording procedures, because sometime as a researcher, you may be collecting variables for maybe 6 months, 1 year, maybe more than that. So in that entire data collection duration, make sure you are using standard formats and you are using consistent data collection techniques. It will help you to ensure accuracy in clinical interpretation. And similarly, it will also assist you to merge your data set from multiple departments, because you are following same standards everywhere. Maybe if you are sometime trying to collect your variables from one hospital, and initially you targeted that, okay, I'll be collecting all the variables from this hospital, so maybe you will be considering 100 patients from one hospital. But maybe later, after maybe a year or maybe few months, you had a discussion with your supervisor, and then they told you that this number of patients are not enough, so you should collect more patients maybe from such and such hospital now. But if at initial stage you have not followed standard collection procedures, it will be difficult for you to merge those two data sets later, that you are collecting from two different hospitals or maybe two different departments. So always make sure a standardization is followed everywhere. And there are several different data recording methods or formats that you will generally find in the healthcare domain. There are structured data sets, semi-structured data sets, and unstructured data set. A little detail about this is discussed in the yesterday's session also by Dr. Shanawaz. So I'm just elaborating it further with relevant set of parameters that you may need to know. There are different characteristics that we may be recording. For instance, in case of structured data, there are some predefined format or numeric details or some coded informations that we expect to get from healthcare variables. So it could be like maybe some patient reports, test reports, etc., or maybe some measurements that we are doing for vital signs of the patient, and they are available in Educate numerical values. Like maybe fever indications you are getting, they are appropriate numbers you are getting, and there is a standard format for measurement of temperature in every hospital, so that you will get with a specific unit over there. So there is a predefined format for everything. So that becomes your structured data. But at the same time, sometimes you will also have semi-structured data, that is in the form of textual summaries, or we can have even a partial structure. That could be like maybe some discharge summaries or maybe nursing notes or maybe OPT discussions that patient and doctors are having. So that is sometimes also in the form of summaries. So that becomes your semi-structured data. And then the third level we have is unstructured data. This is a free form output. We don't have any structure in this, or even the partial structure is also not possible. So it could be like some images, it could be maybe X-rays, CT scans, or maybe ECG waveform, etc., that are free form of outputs, and we have them in that original form only. So these are the three versions you have. Now, it is important to note here that it is not essential that for certain research project you will always find all collection of structured data or all collection of semi-structured or unstructured. Sometimes we have mixed information also. So as a researcher or as a data collection person at the initial stage for certain research project, you have to take care of every format of data, and you have to bring that into a standard format that is useful for the analysis further. So while working on this, let us first understand how this may appear in detail. For the structured data set, we have organized and standardized fields that are stored in the databases accurately. There may be some numerical values. There may be some categorical values also, like yes, no fields or true, false fields, etc. There may be some categorical labels, like what type of diabetes is identified in patient, or maybe some standard codes also may occur, like depending upon the medical terminologies, there may be specific set of codes to represent certain disease statuses. So that may be highlighted in your patient summaries or maybe nursing notes or maybe doctor summaries. So advantage of this kind of data is, the best thing is it is machine readable data, because it is available in appropriate set of numbers, units, and categorical details. It is the easiest one to analyze and visualize, and we call it a ideal data for AI or machine learning training. So if you are a very beginner, you are just starting for the first time with any kind of healthcare based study, we generally suggest that start with the structured data because that will be easier to analyze for you as a beginner. So some real examples in this scenario we can have is like blood pressure range. They may be in this format. Then maybe oxygen saturation levels you can have in this level. And similarly, there are plenty of variables I have listed here. So this is generally the foundation of majority of healthcare data set. But then we have the next scenario with the semi-structured data set. There may be some meaningful clinical information that is not in fixed set of fields. So examples could be doctor notes or nursing progress notes. It could be history of patient illness, maybe discharge summaries, operative notes, or maybe pathology report descriptions. So all of them represent a semi-structured data. So it could be a text-based information, clinical keywords or values or timeliness may be available in that. Or maybe there is a special domain in AI that is generally utilized to understand this kind of semi-structured data, and we call it NLP. I'm not sure if any of you have heard about NLP or not. NLP represents natural language processing. We will not be focusing more on NLP in this particular course, but considering this three-level course that we have associated with it, in the third level, we will have specific case studies on NLP also, like how specific text-based descriptions or keywords, etc., we can utilize directly from the semi-structured data set, and we can create a relevant information from that directly. So this is a specialized domain we have to deal with the text-based data. And this data sometimes holds a rich context that may appear in numerical data set also, but we need to organize it manually or by using NLP-based techniques that can help us to convert semi-structured data into a structured data directly. And there is a huge relevance of even this semi-structured data set as well. Like for instance, there could be some patients that reported chest pain radiating to the left arm since morning, or maybe doctor are writing some summaries about symptoms of the patient. So from there, as a researcher or when you are collecting some data, you could get highlights about patient symptoms directly, and they could become some relevant variables later on. So you may have to extract them based on the requirement. So there could be maybe patient symptom evaluations, maybe patient narratives, or maybe some treatment response patterns, etc., that you could get from these text-based structures. And the third case we were talking about is the unstructured data that could be present in the form of medical imaging, ECG signals, or maybe endoscopy videos or histopathology images as well. These are just some examples I'm giving. Otherwise, there is a very large set of unstructured data also generated in the healthcare community. So this kind of data require special type of dealing in AI domain. We have a special domain in AI to deal with this that we call computer vision. So this is again a complete, like we can say, complete domain to study, a subdomain of AI to study. Similarly, there is a signal processing domain also in AI that you may need to study to understand ECG or EEG waves directly. And then there is a subdomain that is specifically for the feature engineering in the AI modeling. So there are different categories further within in AI. And that depends on what kind of hypothesis we are proceeding with, what kind of research study we are trying to do. And based on that, the selection of subdomain we are going to do further for the analysis. So this kind of unstructured data, although is difficult to understand for a beginner, but sometimes it leads to a high value diagnostic evidence that may be useful for final decision making regarding condition of certain patient. And there are some important units also that you have to keep in mind while collecting your data set. So this is a special advice for the researchers who are entering into this kind of data collection and are planning to conduct certain kind of evaluation using AI in future. Always make sure that you adhere to the unit guidelines, either discuss it with your supervisor at initial level to finalize your standard units, or you can go ahead with the literature, check what standard units are preferred for your kind of research, and then start recording your parameters in those standard formats only for providing better clinical conclusions by the end of your research. And while working on your biological ranges, there are always some references provided in the medical communities. So the doctors may be already aware about these things, but those who are entering into this domain as an interdisciplinary researchers, they need to understand that always consider what are the nominal ranges, what are the initial onsets for certain kind of test report variables, and how you interpret them. That kind of analysis you need to do in at initial stages, so that you can utilize those variables accurately in your decision making process further. It is also important to mention about measurement frequencies and timestamps, because sometimes when researchers collect their data for certain kind of clinical interpretations, they miss accurate findings just because of inappropriate frequency of data collection. See, in medical communities, there are several challenges associated with patient data collection also. Timestamp is always a critical instance, because sometimes even patients are not in a position to visit on every scheduled meeting with the doctor. Like if you are calling a patient every Monday to do the next assessment of their disease level, it is not always necessary that they will be visiting every Monday. Sometimes they have their own reasons. Sometimes their disease is not allowing them to visit hospital every time. So you miss variables in between. There are chances to miss variables. There can be many other reasons also behind this. So having a proper timestamp in your data is very crucial. So sometimes what we say that there are several ways to deal with this. Like sometimes maybe the temperature measurements we are doing. So maybe every 6 hours is your preferred frequency. And depending upon the severity level of the disease, you can even set up a trend, like you can do averaging also with time, depending upon how many readings a day you are getting. Ultimately, maybe you can have a daily average or maybe hourly average for the temperature readings. Those kind of things are sometimes also done, but depending upon what kind of hypothesis we are dealing with. Sometimes, like, it is not possible to have weekly summaries of the patient information or vitals. So in that case, we conduct maybe the monthly summaries. But for that, definitely you need to have long range data, maybe last 5 years data, maybe last 7 years data. Then only it will be possible to do that averaging task also. But if you already have a data of maybe 6 months only, and then you try to average it on monthly basis, so you are just going to have 6 readings for 6 months only. That is not enough for a good AI model. For a proper AI modeling, we need a huge set of information at initial stage, so that AI model can understand the background of the problem clearly. So always make sure that you consider the frequency of measurement very carefully, and it should provide you an appropriate trend, and it should be with reference to your hypothesis. The frequency of recording is very essential every time. However, there are some common challenges that you need to keep in mind. Make sure the missing values are dealt well. Maybe in some future sessions, we'll be talking about missing value treatments also. There are some statistical ways also to deal with the missing values that I suppose we may discuss maybe in level 2 course, because there we'll be deploying the real machine learning and feature engineering terminologies. And the inconsistent naming, all these things basically require some pre-processing at initial stage. So there will be plenty of things that you have to keep in mind as a researcher or as a developer or as a solution provider in the healthcare community that can assist you. Actually, we are here not just the users of AI. While learning this course, we are learning the backend processes also. We are just trying to learn how AI actually works. We are not just looking at the front end of AI where it is making some decisions. We are trying to understand how on the background it is working, so that we can have more confidence on using that technology in our day-to-day practices. Even as a doctor, how confidently we'll be able to use AI depends on how much we know about its back-end procedures. If we know that how it can work accurately, and accordingly we know that this is the way to design a accurate system, then we can develop more trust on the technology, and then definitely we can deploy it on our day-to-day clinical procedures or maybe hospital procedures. But if we don't know how it works behind, we'll have less confidence and we'll not be able to permit it into our day-to-day clinical practices. So that is the reason why we are just learning all these background factors side by side here. So what makes a dataset AI ready in healthcare? So for that, we need to assure that we have relevant predictor variables, that is your input or independent variables. We need a clinically correct target variable. There are clear definitions for every column, and we need appropriate ethical clearance that I'm telling you right from the beginning. The patient privacies are always important. So ethical clearance for using certain data is always essential. And we need to ensure that we have healthy data set with consistent information and minimal missingness. So now coming to the last part of the discussion, that is how real world data set is collected. Now we will come to how at every stage in a hospital environment, we keep on collecting data. So as a researcher, if you are just thinking about that from what sources you may get data, or what are the general input solutions you can have for different vitals, etc., we have like unlimited stages of data collection in the hospital environments or in healthcare sector. Let us have a quick discussion over that further. I'm just taking, for just quick reference, I'll be taking 3-4 diseases at different levels, that how some common parameters will be picking up on different stages of care in the healthcare sector. So I'm just focusing on these 3-4 areas. On and off I'll be talking about them, and otherwise definitely there are plenty of areas based on your research background, your expertise, etc. You can think of other variables accordingly. You will be able to establish that relation easily. So starting with the very first stage, patient registration or admission. That is the very first step of getting any kind of information about your patient. So generally, when patients fill their registration forms, or at help desk or maybe at the reception desk, whenever a patient is registered into the software, there are plenty of initial variables we collect from there. That could include name, age, gender of the person, maybe the contact details, maybe the address of the person, unique IDs or insurance numbers, etc. Those are the initial level of information we are getting. So this could be depending upon what type of hospital it is, maybe depending upon the level of administrations we have or the type of softwares we have behind. So it could be some online data collection or paper-based data collection. You may have documents for that. So these are demographic variables that can help you to understand identity of the patient. They are not particularly related with the disease yet, but still they are mandatory to collect as clinical records. However, it is important to mention that the personal details of the patients will not be utilized anywhere in the research summaries further, until and unless it is you are getting consent of the patient for certain case history specifically. So it is always important to mention, although these kind of variables are collected, but it is based on the legal adherence you have to always follow, that which one of these you can take further or which one you have to skip in between. So this could generally come, like I have taken some sample forms that are generally available in different hospitals, just to help you understand in what form you may get those data. So for instance, if some online admission forms are there, so they may have some direct entries like this: general information about the patient, or sometimes we have this manual filling in of depending upon what type of hospital we are visiting. I have just taken a sample form here from the Bombay Hospital and Medical Research Center, just to understand how the registration process goes on. So here you will find initial details about the patient, all the personal details only we are getting here. However, this is not yet connected to the actual disease of the patient, just the initial information we are getting. Then moving to the stage 2. When the patient is registered with certain clinic or healthcare center, next stage is when they are moving to the OPD or maybe for to the doctor for the consultation. So at that time, they are going to report different symptoms that they are feeling while discussing with the doctor. So the source of this type of data includes patient doctor interactions or patient nurse conversations, where they are taking the clinical histories of the patient. Depending upon what type of model is followed by the hospitals, in some hospitals, the patients after registration go directly to the doctors in the OPDs. In some hospitals, there are some intermediate stages where initial nurses collect initial disease symptoms of the patient, and then with that summary, they go to the doctor, and then the further discussions are followed up over there. So, depending upon from which hospitals you are gathering your data, you may find different types of forms for this. So, there may be different disease cases, like for pneumonia, they may have reported symptoms like fever, cough, chest pain, or breathlessness, etc. And same goes with other areas also, like maybe for the heart attack. These are some commonly reported symptoms at initial stages. So this may appear in several forms again now. Again, I'm taking just some sample formats over here. These are not the actual patient vitals presented here. They are just some sample data sets available publicly online for the research purpose. So you can observe here, like even from the doctor summaries on a certain patient discussion in the OPDs, there are different details you find, like what kind of medicines are prescribed, or maybe what kind of symptoms are reported by the patient, what kind of disease the doctor has identified, or maybe what further progression doctor has suggested. So all those things you will find in this summary, or this may be turned out into a very clean version of the form depending upon how data is entered in the next stage. So in majority of hospitals in India at present also, the OPD summaries are available in this form generally. In very rare cases, the digital version of summaries are available, that is on the other side of the screen. So if we try to record this data in a clean version, we may get something like this, like proper chief complaints of the doctors. So the abdominal pain from last 2 days, that is reported. Similarly, fever symptoms, so initial symptoms are reported. Then what vital doctor has checked during OPD consultation, those are reported here. Then if any clinical note is available, that is also listed. What is the diagnosis, that is also listed very well. What medications are given, those are listed. What doses are given, that is listed. And further investigation type, that is also listed. So this brings you clean version of data. This can be extracted right from these kind of summaries also, and we expect that maybe with time, over some years, there may be some improved versions of OPD consultations in our country also, where everything can be digitized side by side. Although considering the current population level, considering the current burden of disease that we have in our country, this may take some time, but we expect that maybe in coming years we'll have clean summaries maybe in the digital forms directly. So that could make data assessment pretty simple. But yes, from the current stages also, we could identify relevant set of variables depending upon our requirement, even from direct patient records available from the handwritten summaries also. Moving forward with the third stage, for instance, during those OPD consultations, or maybe during any nursing or clinical examinations that had during OPD visits of the patient, there could be several vitals reported. Some of them I have highlighted here also initially, but there could be some detailed summaries also available on the vitals. So that could be regarding body temperature, or maybe blood pressures, oxygen levels, or maybe many other details. So there could be different devices used for that. And it is important to mention that at present, we have even some fitness trackers or wearable sensors also available that people are using on the go basis as well to track their fitness level. So these kind of parameters we can even get from those fitness trackers, or maybe the regular monitoring devices that people keep on using these days on common basis. So those sources again can be documented into proper summaries. So this kind of evaluation sheets from OPDs or maybe nursing colleges you may get, where adequate information about patient vitals may be entered, and based on that you can club your data. Ultimately you will be creating some structured data set, but these are just some raw forms of data I'm showing you right now, and maybe in some coming days we'll be discussing about how this data is available in actual Excel sheets later on that we feed into your machine learning models directly. So moving to the next stage, then if after consulting your doctors or in the OPD discussion, there may be some test suggested to the patient. So again, we have new set of data or new set of vitals or information available from the patient records again. So there could be, like if the person is initially reported to have pneumonia symptoms, so there could be some relevant lab tests or imaging variables required by the doctor for further diagnosis. That could be X-ray findings required, WBC count, or maybe CRP reports required. So the sources also I have listed for these kind of things. So depending upon, again, what type of disease you are studying right now, you may have different set of diagnostic findings from the laboratory test for that. So some of these variables could be purely numerical in nature. Some of them can be available in the form of images, or maybe some of them can be in the form of categorical details or summary in the report itself. So there could be variety of versions of data again from here. So just a general highlight I can give you from some online sources that are readily available for just quick understanding or research purpose. We can see here, like maybe for the ECG report, you can have plenty of numerical variables quickly available. This is just a general analysis shown here for all normal cases, but generally the values will be presented in these tables. They will be entered precisely based on how the patient is right now. Similarly, some lab test reports you can find. So here, the exact result values in the form of numbers you will find, and you can insert them into your data file based on your hypothesis or based on the requirement of your predictor variables. Same goes with the ECG reports also. You may have different types of vitals reported from the patient report, and that you can add into your. So what we are doing here is, like on every level, you are getting some data variables and you are entering them for a collective study at a later stage. And further, in case if the person is hospitalized, if he is admitted to the ward, at that time also several variables are collected on the regular monitoring basis. So this helps you to get longitudinal data, because time-based entries we keep on doing in this case. So vitals in the wards are monitored on the regular basis. They help us to intake like maybe fluid inputs or maybe urine outputs, etc. Those kind of charts will be prepared. Then the medication doses, or maybe how the patient is progressing with those medication doses, that kind of nursing notes will be prepared. And of course, treatment response will be also reported in this. So this will help you to create a time series of data. And depending upon what kind of analysis you are doing, if you are doing a kind of trend analysis, or maybe you need to forecast the impact of certain treatment on the patient after hospitalization on certain disease, that kind of information you can pretty well represent with this longitudinal data. This could generally be available in the form of these type of forms, although the format depends on different hospitals, but generally numerical values are directly available from this kind of data. Sometimes nursing notes are also available, but majority of time exact numerical values you will get. And that will be longitudinal data. So maybe thrice a day or twice a day, those notes are taken by the experts in the hospital areas, and that could be a useful data for longitudinal analysis. Furthermore, at stage 6, in case if some critical unit patients are available, so if they are going through ICU monitoring, there are also several categories of variables we get through, like some continuous vitals are monitored with heart rate, ECG waveforms, or respiratory rate, etc. Then ventilator parameters are also there. critical lab tests that go on side by side, they are also reported, and intervention timestamps also you will find from the sensitive data that we have within the ICU environment. So this information, again, many of you would have seen these kind of ICU monitors maybe on some documentaries, maybe even not even if the hospitals, maybe in some movies, etc. You might have seen this kind of information. So that can be recorded further into specific ICU reports or maybe nurse report sheets, and again exact numerical parameters. Again, as a longitudinal data also you can get from here. Maybe like these sheets are filled maybe thrice a day or maybe 4 times a day, depending upon what kind of monitoring is going on. So that also becomes a relevant data for certain kind of prediction, like maybe if we can talk about the survival chances after ICU admission of certain patient on certain disease onset. So that kind of longitudinal analysis we can do with this kind of ICU monitoring. So further, even from the discharge summaries, you will get plenty of relevant variables. So again, depending upon your hypothesis, if that may help, you can put that into your data files. That could be the final diagnosis after entire discussion or after entire analysis over the lab reports, maybe the hospital stay durations, any kind of complications faced by the patient, then recovery or readmission risks, etc. Everything can be discussed pretty well in these discharge summaries. So they may be again available either in the form of handwritten notes from nurses or doctors, or maybe in some proper digital copies. In some different hospitals you will find this information. So from there also you can extract the relevant set of variables to be entered as a predictors in your list, and they may contribute further in your hypothesis testing. So in some rare cases, maybe further, if we are talking like if the patient does not survive, even after that, there are several data collections going on. So this completely depends on what type of case study you are taking up. Maybe this post-mortem data or mortuary data, etc., that may be also useful at certain levels. So some variables that are collected even after that, that could be like some administrative or legal variables may be there. Some cause of death related information you will find. Autopsy variables are there. And similarly, the microscopic pathology variables or toxicology variables, there is a long list of variables every time you are going to get from here. So even at every stage for the mortality analysis or clinical quality audits, etc., these all variables are widely used. And this type of information is more important for classification analysis, especially when you are judging some survival rates for certain kind of disease conditions. That could be like maybe survival conditions after certain type of heart disease or maybe some tumor disease. Different types of options you can have, and survival chances will be available from this type of information, from discharge summaries and from mortality data basically. So again, several types of forms regarding this you will find in the hospital records, and from there as a researcher you can pick up relevant values and you can put that into your relevant set of data easily. Furthermore, disease-wise post-mortem variables are also possible at several stages. Like for pneumonia, your post-mortem variables may be different. That could be lung consolidation, or maybe you can have septic emboli, etc. Maybe for diabetes cases, there can be kidney fibrosis or maybe pancreatic degeneration. So the variables may differ based on disease-wise cases also. So again, as I told you right in the beginning, that there is a long list of variables, but you need to identify right in the beginning which ones are essential for you. So you have general set of variables also available, and there are some specific set of variables also that you need to identify based on your specific conditions that you have to consider for disease cases. So it could be depending upon whether the person is suffering from pneumonia, diabetes, or hypertension that you were taking for your case histories, and that only you can take for further analysis while working on your special disease cases. Furthermore, there are final storage or mortality data sets also available that you can consider for this analysis. For instance, you can have record categories like death summaries, mechanism, or cause of death, etc. So this could be located at different positions. So if your research involves this kind of variables, that also you can highlight within your system or your data set itself. So while working on all these categories, you need to ensure always that your outcome variables are also well categorized. Like for the binary variable, whether the person survived or died, that could be your target variable in that case. Based on all the critical evaluations that you have done on all previous stages, there could be the final variable that you have in your hypothesis itself. Furthermore, for the categorical and numerical variables available, this could be highlighted in different formats, like maybe time to death or survival duration, or maybe categorical, that could be the cause of death, etc. So with this, all the analysis, I'll come to the summary of this all discussion that we have done till now. So we have talked about how the healthcare data set becomes useful for data science or machine learning based forecasting, and how these both domains can uh, work together to provide some relevant outcomes to the communities, whether it is for the patients, for the doctors, or for clinical reasoning, for the caregivers. At every step, this collaboration of both domains can be a great outcome for the, we can say, on the national level, on the international level, everywhere this is on a great demand these days. So this can bring us some ready to use AI based systems that can do clinical analysis, and that can help us to generate medically sound diagnoses and outcomes, so that we can trust or we can rely on these outcomes easily. So with this, I would close it right now. And if we have any queries, we can do that. And we have another expert also with us that will be taking a few minutes further to just give you some glimpse about data sets and how in the medical community the data fields may be available. So that kind of information further also they will be providing to you. So I suppose since I'll be available here, so we can first listen to our next expert, and after that we can together have all the discussions or queries from the participants directly. So I hope that will be fine for everyone right now, if you can proceed like that. Okay, so for that, I'll be introducing our next speaker of the day that we have with us, Dr. Ashok Kumar, who is a nursing tutor at National Institute of Nursing Education, PGIMER, Chandigarh. We are privileged to have you with us on this second day of the course, sir. If you just talk about the awards and honors of Dr. Ashok Kumar, there is a long list. He has received NSS Karamveer Award 2023, Best Researcher Award 2022, CVSN Stroke Nursing Symposium Travel Grant in 2021. Similarly, from the American Heart Association, he has received multiple awards over the years. And if we talk about the research and statistics associated with Dr. Kumar, they say there is a long list of national and international publications, the research papers he has presented in national and international platform. And similarly, he has also guided multiple PhD theses. He is also principal and co-principal investigator around 6 different research studies, including ICMR funded studies as well. So he has more than 10 years of experience in data analysis and sample size calculation, one of the renowned speakers in the community these days. So I would like to hand over the session to you for the discussions right now. And maybe after that, we can take up the queries of the participants.
Thank you, Dr. Jagriti, and thanks for wonderful session, in-depth session, and excellent session as well. So, good evening, all participants, and I want to give thanks to organizers to give me this opportunity. So, I will not describe and I will not take much time, there, but I want to highlight some things that how can we transform these unstructured, structured, or semi-structured data into Excel sheet and by using that Excel sheet, we can perform for like machine learning and artificial intelligence and machine learning. Okay, so I'm going to share my study screen. Okay, I think. So I think most of the things have covered by Dr. Jagriti in very well manner. Okay, so this is a little bit about what is data or variable. So anything in this universe and beyond this universe, these are data or variable, anything. Okay, for example, name, for example, age, for example, goals, for example, runs in the like player in cricket, we can say anything. So these are, for example, disease severity. Okay, for example, how many stars. So these are anything in this universe or beyond this universe, these are called data or variables. So mainly this is discussed in detail by two earlier presenters or resource person. So data or variable, sometimes we are using variables, sometimes we are using data. So it is basically divided into two, that is quantitative and qualitative. So for quantitative, we are using regression model, and for qualitative, we are using classification model in machine learning. Okay, so when we what do you mean by quantitative? Means number, numericals. Okay, any number, 120, 15.4, 26.3, whatever. 120 means systolic BP. Okay, 15.4 means any hemoglobin level. Okay, whatever. And 26.3 in medical field, that is like level of urea, something like that. So these are quantitative. And qualitative, it is also called categorical. For example, good, bad, soft, hard, bleak, white. Okay, we are these are not numerical, these are just a description of anything. So quantitative data is further divided into continuous data and discrete data. Okay, so these quantitative and qualitative data we have to enter in our Excel sheet to perform our machine learning, okay, using artificial intelligence, or even I want to say that basic statistical analysis. So first we have to understand about these, what do you mean by quantitative data and what do you mean by qualitative data, so that we can handle these data very easy. So in quantitative data, as I told you, that it is further divided into continuous data and discrete data. Continuous means we can give decimals, we can give fractions, okay, and usually measures. For example, 165.6 centimeter, that is a height. So when we can present any data or any variable in decimals, okay, so that is called continuous data. For example, age, height, weight, BMI, systolic BP, diastolic BP, hemoglobin level, electrolytes, for example, sodium, potassium, chloride, okay, exam score, anxiety score, depression score, CRP values, anything. So these are called continuous data. We can give decimal, we can give decimals, or we can present in the form of fractions. Okay, now discrete means whole number, we cannot give decimals. Okay, we cannot give, usually we count. For example, number of family members, how many number of family members, 2, 3, 4, but we cannot say 3.5, 2.5, okay, 10.5, we cannot say. For example, pulse rate, like 60, 80, 90, 100, 120, but we cannot say 90.5, 80.5. Okay. So these are called discrete data. And now number of chairs, for example. So suppose if there is chair is broken, but we cannot say it's a 3.4, 3.5, okay, chairs, but we have to say it's a three chairs, I think in working condition, and one chair is in broken. Okay, we have to say according to this. So but we cannot give any decimal. So these are called discrete number. Okay. Now comes to qualitative data. So these are it is also called categorical data. So this is male, female, religion, Hindu, Muslim, Sikh, Isai, color, black, white, behavior, personality, introverted, extroverted, okay, day, night, alive, dead, good, bad, okay, improved, not improved, okay. So these are called qualitative or categorical data. In categorical or qualitative data, if we have only two category, it is called binary. For example, male or female. For example, good or bad. For example, yes or no. For example, present and absent. So these are called binary, categorical or qualitative data. So first we have to understand the basic of these data or variable, and accordingly we have to enter these data in our Excel sheet to perform machine learning using artificial intelligence. And now these are the stages of data processing. So first what we have to do, we have to collect data from assessment sheet, observation chart of nursing notes or doctor notes. We have to collect these data. Then we have to prepare data accordingly. For example, we have to see the units of the data. If there is any missing data, we have to handle that missing data also. Then according to, we have to prepare these data, and then we have to input our data in Excel sheet, and after we have to do process the data. Now in using this machine learning and artificial intelligence, then we have to interpret data according to regression model or classification model. Then we have to store this data for future references. So these are the stages of data processing, and when in next sessions, when it will be done for machine learning using artificial intelligence, then we will see that which stage we have to cover. So first today we have to cover data collection and then data preparation. So here in real world we have to see the data, we have to collect data, or we have to get information at the bedside, and later we have to store these data in system for analysis. For objective of this, what we have to do, this help learners understand how disease variables originate from routine documentation. As Dr. Jagrati explained very well about how to collect these data from the documentation or from routine assessment sheets. So these include health assessment sheet or observation charts. From these observation or health assessment sheets, we can collect vitals, for example, systolic BP, diastolic, respiratory rate, pulse rate, temperature, etc. We can take intake and output charts, okay, like urine output if I want for disease kidney disease patients, okay, CKD patients, we have to keep in mind about intake and output. Penny scale, if patient is having post-operative, so we have to assess Penny scale also. And if GCS, that is a Glasgow Coma Scales, mainly assessed for neurosurgical, neurological, or head trauma, or that is okay. So we have to assess these observations from nursing notes, from patient charts or observation sheets, assessment sheet, and doctor notes. So this is example of, and various examples were given by Dr. Jagrati how to collect data. Okay, so this is a nursing assessment chart, and we can see here we can get BP, pulse, temperatures according to day. Okay, and we can get respiratory rate, O2, inspiration O2, SpO2, PAN score, sedation score, we can get according to time and date. So we can get these informations, and we can fill these informations in our Excel sheet to do artificial intelligence machine learning to perform these things. Okay. So these are, it is explained very well by Dr. Jagriti. So I will not give much time, but we have to explain about what are the data types we have to think. And these are the variables. For example, for symptoms, we have variable cough, fever, and shortness of breath. So where it comes from, these comes from patient's assessment notes. We know very well vitals, and these are the vitals, and these are from where we can get from vitals monitoring. Okay, so these are the data types, these are the examples, and where these data we can take from. Okay, generally we are taking from patient's assessment notes, nursing documentation, discharge summary, and it is very well explained by Dr. Jagrati. So now let's look and understand the data type. So I want to give on Excel sheet. You can see, okay, you can see this Excel, and we have to think about each and everything. Okay, so this is Excel. We have to enter. You can see here in column 1, this is a serial number. So we have to give serial number in column 1. And this is name of the patient. And we know about very well. Okay. Now this is a age. So we have to enter age. But please remember that we have to enter age in same unit. Okay. So if this age is entered in years, so for all patients, we have to enter age in years only, not in months and days. Suppose it is entered in year. Okay. So next patient, we have to enter age in years, not in months. So please remember these things. Okay. Then this is, so can anybody tell age is which type of data? It is quantitative data, or it is a qualitative data? If it is quantitative data, then which type of data? Continuous data or discrete data? Can anybody tell in chat which type of data this is? Then we can, age is a discrete. Okay. Okay. So age, okay. So this is a quantitative data. Okay. So this is generally it is not a discrete, it is a continuous type of data. Okay. So age, what we are taking it is a continuous type of data. So it is a quantitative type of data. So can tell about what do you mean by age or gender. So you can see here we have given code here. 1 is for female and 0 is for male. You can see here. Okay. So we can give enter data according to this. So here gender is a male or female, and we have given code here. So can anybody tell me which type of data this? Anybody? Gender is categorical. Okay. So categorical further divided into, okay, it is type of binary data. Okay. It is type of binary data, male and female. Okay. So this is, okay, discrete or descriptive? Okay, this is a categorical. Okay, so this is the duration of data, duration of illness, in months. So we have to enter all the data of duration in months. We cannot enter for some patients in year and some patients in months or some patients in days. Please remember this, as Dr. Jagrati already explained that how to enter data. So we have to make similar units for all the this variable duration of illness. So these are in months. So can anybody tell me month is which type of data? If duration of illness is which type of data? Continuous, quantitative, or categorical? So if you understand these things, then we can you can think about which model we can perform, classification or regression model. Okay, so we have to remember this, which type of, if we understand this type of data, then we can perform and we can choose which model we can use for machine learning. So these are, so according to this, these are age, gender we can get from patients, like socio-demographic. These are duration of illness. Okay, duration of illness, and these are the comorbidities. HTN means hypertension. 1 is present, 0 is absent. Okay, so these are the comorbidities. So diabetes, hypertension, smoking. Okay, these are the risk factor, alcohol, obesity. So we have entered this data in the form of yes, present, or absent. Okay, so present means 1 and absent means 0. So we have entered this data in Excel sheet. You can see here in the form of. Now, these are the CAD, that is a coronary artery disease, family history, dyslipidemia, okay, in the form of 0 and 1. 0 means absent, 1 means present, okay. So this is height, HT means height, weight, and this is BMI. We can see here, you can see here that in height, you can see here, for some cases, it is entered as in meter, and in some cases, it is entered in centimeters. So this is the wrong way to enter these data. Either we have to enter height in meter for all patients, or otherwise centimeter for all patients. So we have to correct all these entries, okay, before doing classification or regression model. Otherwise, this will give error or the accuracy will not be maintained. So please remember this, okay? So what we have to do, we have to correct these entries and we can make all these in centimeter. You can see here. Now we have to see 160. According to this, we have to correct our entries before performing any analysis. Then we have to see, and now you can see here, this is entry of BP. It is systolic by diastolic. So please remember, in this form of BP, we cannot perform analysis. Please remember, in this form of BP entry, we cannot perform any analysis. So what we have to do, we have to enter data systolic BP in separate column and diastolic BP in separate column. Please remember this, okay? So what we have to do, we have to click here, then right click, and we have to click, okay? We have to click here on nearby this S column. Okay, you can see my error. There is down arrow, black arrow. You can see here. Then I have to click right click, and then we have to click insert. We can get a one column here. Then I have to write down SBP. And then again, I have to click here. You can see my error on T, arrow on T. Then I have to click right. and then insert. It is for DBP. Then I have to like enter data 118 and 79. You can see here. We have to enter data according to this. Then we can do analysis, or we can perform regression model or classification model. Otherwise, in this set of data or in this set of data entry, we cannot perform. So generally what happen in like when doctors write down electrolytes, so what they are writing? They are writing sodium oblique potassium oblique chloride oblique urea oblique creatinine, something like that, oblique oblique oblique. So we cannot write down in one column these things. We have to make separate column for sodium, separate column for potassium, separate column for chloride, as such. Then we have to perform data entry so that we can do like analysis. Okay. Now you can see here in WBC. Okay. In WBC, you can see in some cases it is written 9.5. Okay. And in some cases it is written 10K. 10K means 1000. So it is written according to this. In this condition, also we cannot perform any analysis. So what we have to do, because this is a quantitative type of data, it is a continuous type of data because it is having decimals. Okay, so what we have to do, we can enter, it is, sorry. So what we have to do, we have to enter data according to this. This is 10,000, 11,000, 11.2, 9.5, and 7.1. We have to enter data according to this. Then we can perform analysis. Otherwise, for example, sometimes what happened, this is only 10. So here it is written 10,000 here. Okay, in this condition. Here it is written 18,100 according to this. You can see here. In this condition also we cannot perform correct analysis. We can perform analysis, but it will not give accurate result because the data entry is like you can see there is an error in data entry. Here it is 10,000 we have entered, but we have entered here only 11. So it is also 11,000, but the entry of the data is I think something different. So what we have to do? Otherwise, I have to correct all the data entry. Like I have to make in thousands according to this 11,000, 11,200, 9,500, 7,100, 9,600 according to this. Otherwise, I have to write down here. It is a 10 means 10,000. It is 18.1,000 because we are getting these data from patient's record or patient's assessment notes. Okay, records. So we have to enter, and I can write down here WBC underscore 1,000. Okay, I can write down here. But please don't write down here according to this, as I told you. For example, here it is HB means hemoglobin. Sometimes what happened, we enter data according to this 14.7. Okay, here we are write down gram per deciliter. Okay, we are writing here, okay, gram per deciliter something. Okay, so if we enter data according to this, okay, it is correct entry. It is correct entry. Okay, 14.7 gram per deciliter, 16.7 gram per deciliter. It's right. Okay, because from patient assessment notes we are getting this. But please remember, if we enter data according to this, we cannot perform any analysis. Okay, so what we have to do, either I can write down HB underscore gram per deciliter, and I have to remove all the things. Please remember this. Okay, so this is correct data entry. So please remember, first, if we have correct data entry, then we can perform our analysis or machine learning. And this is our outcome at 1 year. So these are the predictors of MI, okay, myocardial infarction at 1. So this is our outcome or target variable, and these are independent variable or predictor variable, we can say. So for this, we have to make our model, classification model, because this is our outcome variable in the form of categorical binary variable. So as Dr. Jagrati ma'am told that for binary variable or categorical variable, we have to choose classification model. And if our outcome variable is quantitative variable or in the form of numerical variable, we have to go for regression model. Okay. And these are the semi-structured variables. Okay. Semi-structured data we can see because it is in text form. So if you want to do like for analysis, so first we have to convert into coding, and then we can perform analysis on this. Otherwise, we cannot perform analysis on semi-structured data or even unstructured data. And in like this is a data sheet, so we can perform coding sheet here in Excel sheet for our future reference. For example, in gender, I have given male age 0 and female age 1. I can make coding sheet here for our future reference. Okay, we can make coding sheet here for other variable in coding variable, categorical variable I can make. So this is, I think you got, and if you have any like questions regarding, you can ask. Okay, thank you very much.
Thank you very much, sir, for your valuable explanation on how variables are recorded on Excel sheet.
Thank you.
So with this, we are here to have any kind of discussions or queries on the topic. If anyone has, you can maybe post in the chat box. We are here to help you with any of the pointers on today's discussion.
Excuse me, ma'am.
Yes, please.
Can I ask now?
Yes, please.
Okay. Regarding the discrete versus continuous variables,
Yes.
It was mentioned that age or any duration related information is a continuous variable. So, but they technically are not mentioned in decimals usually. So, how
Right.
do we interpret that as a continuous variable and not a discrete variable?
Yes. See, age is treated as both continuous and discrete variable, and it is always depending upon the context or how it is being measured. For instance, it becomes continuous variable, especially when we are mentioning clear months and year and maybe days also, like maybe 25.5 years. So that would include 5 months in addition to 25 years. And it becomes a discrete variable further when we are counting in the form of whole numbers only, like 5 years, 10 years, 15 years. So it completely depends on the representation of the variable. Sometimes a similar type of variable can be treated in both ways. So final representation, like sometime we have mixture of data, as we have seen recently in the Excel sheet. Sometime we have mixture of data and then we standardize it into a single version. So maybe initially you have discrete version of data, you standardize it further into continuous, or maybe initially you have continuous version of data, then you discretize it by changing those decimal points further.
Okay.
So both ways it is possible.
Can I add a follow-on question to this?
Yeah, sure.
Yeah.
Sure.
So if we are going to predict the age, assuming age is the variable which we are going to predict, so you based on what you said, so we can predict age as a discrete content, like let's say what is the age group in which patients are developing a disease.
See, for
So
that we have a specific analysis. See, when you want to conduct a number-based analysis over age, considering the prediction in the form of exact years or numbers only, then it becomes a regression analysis. But if you are doing group-based analysis, like if the age you have initially converted into a group sequence, that could be like you are trying to analyze if diabetes is affecting maybe people below 25 age group, maybe people between 25 to 50 or beyond that. So you create three groups of age out of that, and then it becomes a class variable or a categorical variable on which you conduct classification analysis. So treatment over a variable decides what type of analysis you are going to conduct on it later at a later stage.
Thank you. Thank you, ma'am.
Okay.
Ma'am, I have few doubts.
Yes, please.
So I actually come from a medical background. I don't know how the model works, but I wanted to know if there are like diseases which do not have like a gold standard, like how we have glucose for diabetes. We don't have such gold standard for those kind of diseases. Then how do we choose the features? Because like you said, if we choose some features which are not relevant to the disease, it might end up giving us a noise.
Right.
Yeah.
So see, although in majority of cases, the case studies that I have conducted with the healthcare variables till date, we generally discuss it with doctors itself that what variables they find more relevant to conduct analysis further. So as you are already from the medical background, so you may be well versed with that. But then there comes the second area also, when you don't have gold standard variables initially. So in AI modeling, there is a specific branch, we call that feature engineering. So in that feature engineering branch, we have specialized variable selection techniques that are statistically influenced, where we try to identify relationship between predictor variables and the target variables, and how well the predictors are contributing in prediction of the target variable. Based on that, we calculate importance scores of every feature, and those high scoring features only we use for the model building process.
Got it, ma'am. So we first conduct the feature engineering wherein we select the features and then we build a model with those features.
Right.
Ma'am, I have one more question.
Yes,
So
please.
when we try to enter the data into the Excel sheets, so our discharge summary in our hospital is very like organized, like structured, like the one which you showed us. So is
Okay.
there any, so right now what we're doing is manually sitting and entering all the details in the Excel sheet. Like we look into it. So are there any tools that we can like extract the details from the PDF and import into the Excel?
Yes, indeed, you can do that. If on the stage of developer, we have to talk this, there is natural language processing, a specific field that works on the textual data directly, that talks about discharge summaries itself. From there, it can extract relevant variables by developing the backend models specialized for that area only. But there are some generalized tools also, like if you update your discharge summaries or maybe OPD summaries into ChatGPT also, while making a ChatGPT agent. Note that I'm not talking about general ChatGPT. I'm talking about agentic ChatGPT, where ChatGPT is acting as a medical professional, and it can even extract all those relevant variables from your discharge summaries itself.
I will try that, ma'am. Thank you.
Yeah. Okay. Any other queries, please? If anyone is not able to unmute themselves, they can even post in the chat box. And if not, definitely we have many other days further to discuss. So even if you have any queries later stage, we can discuss that further. We are already ahead of time, so I have an apology for taking much of your time even after 8. But we'll just try to make sure that we are delivering the most relevant information in every session to all of you, and that could be practically useful at some stage. For making a ChatGPT agentic, you just have to use right set of prompt. In that case, there is no need to purchase. Even the free version can do agentic analysis up to some level. You just have to assign it a prompt that states clearly that ChatGPT has to behave like a professional medical expert in such and such field, and then it acts accordingly. So this is all prompt story basically. You just need to put right prompts into that. Yeah, that's right. So, okay. So everyone, if you don't have any further queries, we'll meet again tomorrow right at 6 p.m. and we will discuss furthermore several details on the topic. Thank you very much for your patient listening, and we'll have much more to learn further. We'll meet again tomorrow. Thank you very much.